Now we're going to do another ellipse problem. We've got to find the center, foci, and the lengths of the major and minor axes of this ellipse. 4x squared plus 9y squared minus 18y equals 27. Now this is probably in a very confusing and muddled form, but again we must apply the same techniques we always have. We look at this muddled up non-standard ellipse and we look at the standard equation for an ellipse. And we try now to rearrange this equation to make it resemble the standard form as much as possible. There are various ways of doing this because it's all algebraic. I personally have the technique I've written down here, but you may have your own. The end point must be what I've just circled there in red. Okay? You may have your own technique. I'm just going to explain how I normally do it. I normally would divide through the entire equation by the lowest common multiple of the factor multiplying the x squared term and the factor multiplying the y squared term. The reason being we don't want factors multiplying the x squared and the y squared, because in the standard equation we don't have that. We don't have anything multiplying the x squared, we don't have anything multiplying the y squared, except for 1. So that's what we want this equation to resemble. So I divided through by 36, which is the lowest common multiple of 4 and 9. I did some algebraic manipulation here. I completed the square, as we always do. We almost always complete the square when it comes to conic section problems. And by a little rearrangement, I got x squared over 9 plus y minus 1 squared over 4 is equal to 1. Now I've got it in standard form. The next step forward, what now can we discern from this rearrangement? We can tell now that the center is going to be 0, 1. Hence, I found the center, one of the three things I'm being asked to find. Second thing, we can see that the x denominator is greater than the y denominator. Hence, clearly, the major axis is the horizontal axis, and the minor axis is the vertical axis. So we know now which axis is which. Now, how do we find the lengths of these axes? If, as we mentioned several times, in the standard equation of the ellipse. If a squared is 9 and a represents half the length of the major axis, half the length of the major axis, or the horizontal axis I should say in this case, then a is 3 and therefore the whole axis must be 6. Simple as that. If b represents half the length of the vertical axis, then b squared, and if we know that b squared is 4, then we can deduce that b is 2, and therefore the whole vertical axis, in this case the minor axis, is 4. Hence we are able to determine the major axis length is 6 and the minor axis length is 4. Now how do we proceed now to finding the foci? We're going to use the same relation as we did in the last problem. Remember though that in this case, as I always stress, b refers to half the length of the minor axis, a refers to half the length of the major axis, and e refers to eccentricity. If we substitute the values we found, 4 is equal to 9 times 1 minus e squared. E is square root 5 over 3. Now, at this point, let's think to ourselves, what does the ellipse look like? We know it's going to look something like this, because we know that the major axis is horizontal. And let's draw that center, 0, 1. We mentioned earlier that an ellipse will have two foci either side of the center of the ellipse that's an equal distance from the ellipse. So you'll have one focus here and one focus here. We said this distance between the center and each of the foci is AE, where A is half the length of the major axis. So if we find AE, which we can in this case, 3 times root 5 over 3, which is root 5, we now found the distance between the center and the focus. Now we can find what the coordinates of the foci are, and it happens to be root 5, 1 and minus root 5, 1. It's very well worth carrying out these steps on your own as I do the problem, and you'll be astounded how much you learn from it. Alright, so do try and take initiative and apply your own understanding to the problem, and you'll see probably where you're going wrong and where you're having difficulty. And it'll really help you learn this material much quicker. Okay, thanks for listening. We'll do one more problem like this in the next video.